Hello students, in this video I want to show you how we can use using Microsoft Excel how can we graph uh, uh, variables and obtain the equation, right, corresponding to the data that we are using. So let me say that I will make a graph of charge 1 versus force, right? So according with the Coulomb's law, force is equal to uh, K times Q1 times Q2 divided by the square of the distance between the particles. Q1 and Q2 are the magnitudes of the charges 1 and 2, and K, remember that is the Coulomb constant. So in this case, I will keep constant the distance between the particles. I will keep constant the magnitude of the charge 2, and what I'm doing is just changing the values of the charge 1. Right, so suppose that I was doing the experiment and I got for those values of the charge 1 the values of force that you see in the right column, in the column B. Uh, Charge 1, Q1 in this case, will be my independent variable, so it will be the variable in the x-axis, and the force will be the dependent variable, so it's going to be the variable in the y-axis. The independent variable is the variable that you will manipulate, so it's a variable that does not depend on other variables, so it's the variable you will change to see how are reacting, the other variables. And in this case, charge 1 will be my independent variable. So it will be the variable that will be changing the magnitude. And then I will see how my dependent variable, that is the force, is going to respond, to each change in the magnitude of the charge 1. Right, so as charge 1 is my independent variable, it's going to be in the x-axis. As charge 2, force, sorry, is my dependent variable is going to be the y-axis. Once we have these values ready here, so we did the experiment. In this case, these values are not corresponding, with the experiment. These are values that I took randomly, right? So once we have the data ready, we're going then to click in insert, and we're going to click in insert a graph. We select in this case an scalar XY graph. I'm going to click in this graph over here. So when you have this in your board, this in your screen, now you make a right click and then you say select data. When you say select data, you say, okay, I'm going to add data here. So I am talking about, I can say this is Coulomb's law. Here in series name, we say Coulomb's law. Series X values, well, I said that the charge 1 will be the variable that is going to be in the x-axis, so it will pick these values over here. And now to pick a series y values, I have to erase what I have over there, and then I will just select the values of the force. So when I do it, I am ready then to see my graph. So look at how my graph looks like, right? Now I can start just, for example, working a little bit in how the graph looks. So I'm going to say, okay, let me select axis titles. So I'm going to say that this one here, is the force. Okay, so I'm going to click here and say force. And then here, what I have is charge 1. I'm going to select charge 1 here, right? Oh, it's charge 1. So when I have, the cosmetic part ready, I'm gonna say, okay, I have these 4 dots, right? So I will find what is the line that better fit those values, those dots, those points. So I will make a click on these points. So I will make a right click, and I'm gonna say add the trend line. So when I add a trend line, you know, now I have the line that better fit, the poems, right? The data that I have. This is the line that better fit the data. But we need to find the equation that describes, this line, right? So I will make a click on this trend line, and then I will go here back, and I'm gonna say display the equation on the chart, right? And this is the equation, you know. So I will move the equation a little bit. I will just make it bigger, a little to see the equation. And as you see, what I have is a linear equation. It makes sense because the relation between the force and the charge one is a linear relation. The formula basically says force equals K times magnitude of the charge 1 times magnitude of the charge 2 divided by the square of the distance. So the relation with the charges, is a linear relation, and an increase in the charge implies an increase also in the force. So I got here the equation is the equation of a line. And then if you go back to your knowledge of college algebra, you will remember here that in this equation y equals 4.5x plus 2.1, 4.5 is the slope. So 4.5 is the slope. In the lab, I ask you to find the slope, and then later following some steps that I gave you, you will be able to find experimentally the Coulomb constant, right? So remember that these y values that you see here is basically the force, right? And this x value you see here is the magnitude of the charge that you select. So you just pick the value of the slope from the equation. You know now that the slope of this class is 4.5, and then replacing that slope later in the lab, following the instructions that I gave you, you will make this slope equal to one expression that I gave you. You will be able to find from that formula the magnitude of the Coulomb's constant. In the practice, make sure that you are working in coulombs, the charge in coulombs, the distance between the charges in meters. So you must make a conversion from centimeters to meters. You have to make a conversion from microcoulombs to coulombs, and then you will have the force in newtons, and you're going to have the Coulomb constant in units that are Newton meter square divided by Coulomb square, right? So that's it. That's how we're going to use, in this case, the Microsoft Excel, the tools of Microsoft Excel to obtain the slope of the line that is describing the relation between the two variables. And then we can just move forward with experiment and later calculate the error, the percentage of error between the two values, the theoretical value and the experimental value. But well, you must study carefully the lab just to and follow instructions carefully just to do all the calculations that are needed. So thank you for your attention. I hope this video will be useful for you.